Hey guys, welcome to this video on the Python programming language and machine learning, more specifically on artificial neural networks, and even more specific than that, on deep neural networks or deep learning. So in this video, we're going to create a program that predicts if the price of a house will be above the median price or not based off of its features using deep learning. Now, currently I'm on Google's website called colab.research.google.com, and the reason why I'm on this site is because it makes it really easy to get started in programming. All you need is a browser, this URL, and a Google account, and you can get started programming in Python right away without having to install Python onto your machine or computer. All right, so let's go ahead and get started writing our program. First thing I'm going to do is click File and then click New Python 3 Notebook here, where it's going to open up a new tab and a cell for us to start programming in Python. So first thing I'm going to do is create a description of what this program does, and this program predicts if the price of a house will be above the median price or not. And I'm going to come down here, down the line, based off of its features using deep learning. Okay, so first thing I want to do is import the dependencies. And so I'm going to import the machine learning package or library called Keras. So from keras.models, I'm going to import the sequential method, which is going to initialize our artificial neural network. And also from keras.layers, I'm going to import the dense method. And this right here will tell us the number of layers and neurons per layer, and activation function of each neuron. Activation function. Okay. Then I want to use a machine learning library or a package called sklearn, so I'm going to import that as well. So from sklearn.model_selection, I'm going to import a method called train_test_split, and this will be to split the data into training and testing sets. Okay. Also from sklearn.preprocessing, I want to import the min max scalar method to scale the data. All right, and I want to visualize the data, so I'm going to import matplotlib or lib.pyplot as plt, and then I'm going to import pandas as pd. All right, so let's go ahead and run this, and hopefully there are no errors. All right. Oh, it looks like there are. So I might have misspelled something. Let's see what the issue is. So from keras.layers, import dense. So here, let's see, we have keras. I misspelled keras with a A. All right, so let's go ahead and run this again. And now everything seems to be working fine. All right, so let's go ahead and create a new cell. And now we're going to upload our data set and store it in a variable. So we're going to upload it and basically load it. So to do that, because I'm using Google Colab, I'm going to use one of their packages or libraries called google.colab to get the data from my computer. So from google.colab, we're going to import files. And then I'm going to create a variable called uploaded, and I'm going to set it equal to files.upload method. And so this will allow us to upload the file, and the file that I'm going to open or upload is called housepricedata.csv. So I'm going to create a variable called df, which will be short for data frame. And I'm going to set it equal to pd.read_csv, and I'm going to give it the name of the file that we have now uploaded, right? Well, we haven't uploaded it yet, but we're going to upload it, and it's called house price data.csv. And then I want to, oh, let me take that back. All right. Then I want to print the first 7 rows of the data set. So here we're going to print the first 7 rows of data. All right. Now I put some more comments in here, like load the data, and then right here I put upload the data. So let's go ahead and run this, and we can see that we get this little option here. I'm going to click choose files to upload a file, and we're going to choose house price data and open it. All right, and now we see that it loads the data into our data frame called df, and then it prints out the first 7 rows of data. All right, so now if we count the columns, we'll see that there are 11 columns. So 1, 2, 3, 4, 5, 6, 7, 8, 9. Just gonna scoot this on over. 10, 11. And then the 11th row, or the 11th column here, is the target column. So it contains all of the target variables. All right, it's gonna scroll back on over, and I'm going to create a new cell. All right, and here we're going to convert the data into an array. And to do that, all I have to do is, well, I'm going to create a new variable first called data set, and all I have to do is set it equal to our data frame dot values. And we can print out the data set just to see what it looks like. So I'm going to go ahead and run the cell, and we can see that it prints out an array of data. All right, so I'm going to go ahead and create a new cell, and here we're going to split the data set into independent and dependent data sets. Okay, so I'm going to create a variable called x. This will be the independent data set, and I'm going to set it equal to data set bracket colon, and then I want so the colon tells me that I want all of the rows, and then I want all of the columns from index 0 to 10. So that last one is not inclusive. So here what we're doing is we're getting all the rows from columns 0 to 10, and so we're not including that last column there. And why is 10 the last column is because we start at 0 and not 1. Okay, so now I'm going to create another variable called y, and I'm going to set it equal to data set as well, and we're going to get all the rows from data set, but we only want one column. We want the last column, so that's column 10. And so here what we're basically doing is getting all of the rows from column at position 10, which is the 11th column. All right, and so I'm just going to run that. Okay, and now let's go ahead and add a new cell. Now that we've split up our data into our features and then our target. So our features are our independent variables, and our target is our dependent variable. All right, so now we're going to scale our data. So we're going to use the min max scalar method, and this is from pre-processing, and it scales. I want to say here which scales the data set. the data set so that all, and I probably need to go to another line here, so that all the features lie between 0 and 1, and that is inclusive. So I'm going to create a variable called min underscore max underscore scalar, and I'm going to set it equal to that method min max scalar. All right. And then I'm going to create another variable called x underscore scale, and I'm going to set it equal to our variable that we just created called min max underscore scalar dot fit, and we're going fit underscore transform, and we're going to transform our features, so our independent data set x, and then let's print out x scale. So let me go ahead and bring this up a little bit and let me run this. Okay, and now we can see our data, which is now scaled from values, or between the values 0 and 1. All right, so I'm going to create a new cell, and now we're going to split the data into, let's go with 80% training and 20% testing and validating. And then what we want to do is split that testing and validation set 50-50. So we're going to split that 20% halfway, right? So half and half, 50%. So that means that we're going to have 10% testing data and 10% validation data. Okay, so now I'm going to use that method called train test split. So I need to create a few variables. So I'm going to create a variable called x underscore train, x underscore val underscore and underscore test. So that's our validation and testing set. They're going to be together at first, and then we're going to split those up. And I need to do the same thing for y. So y underscore train and y underscore validation underscore and underscore test. Okay, and I'm going to set it equal to that train underscore test underscore split method, and we need to tell it what data to split the data on. So we need to tell it the features, our independent variables, and so we have transformed that to x underscore scale. So that's what we're going to input here, x underscore scale, and then we need to tell it the target, so that's y, and then we need to tell it the test size, and I'm going to put the test size at 20%, so we just put 0.2 here for 20%. All right, and now right under it, we're going to split that x val and test data set. So I'm going to create some new variables called x underscore val and x underscore test and y underscore val and y underscore test, and set it equal to train underscore test underscore split. And now we're going to split it on the x underscore val underscore and underscore test set, and the y variable, or the target, will be y underscore val underscore and, oops, I didn't put an underscore here, y underscore val underscore and underscore test. And we're going to split this 50%, so the test size will equal 0.5. Okay, so let me go ahead and run this. All right, it looks like there are no errors. And what I'll do here is I want to print the data set. So I'm just going to print the x underscore train dot shape, the x underscore validation dot shape, the x underscore test dot shape, the y underscore train dot shape, the y underscore val dot shape, and the y underscore test dot shape. So we can see the data. Okay, and so what are we looking at here? I'm gonna put in the comments here. This is the training. Well, let me see here. The training set has 1,168 data points, while the validation and test set have 146 data points each, and the X variables have 10 input features. And then let me go ahead and go down one while I make it more readable here. So I will say the X variables have 10 input features, while the Y variables only have one feature to predict. Yeah, that's not even important. I won't even put that. So I think that's enough information of what's going on here. And the Y doesn't have anything to predict actually. So I don't know why I put that. But this right here should explain what we're seeing down here. All right, so let's add a new cell. And finally, after all of this data preparation, we get to our model. So now we're going to build the model and architecture of the deep neural network. Okay, so to do this, all I have to do is say model equals. So model is a variable that I just created, and we're going to use that sequential method. And so this right here, it initializes the artificial neural network. All right, and oops, let me exit this. I did not mean to create a new cell, just press enter to go down one. And we're going to add some of the layers. So model dot add, and the layers are from that dense method. And so we're going to add the units, which are the number of neurons at this specific layer. So right now this is one layer. The activation function will be ReLU. And for this one layer, I need to tell it the input dimensions. So we have 10 features, and that's why we put the number 10 there. Okay, so to make this a little bit easier, I'm going to do what I should have did for the train test set, and I'm just going to highlight it, click on Control C to copy it, and then Control V to paste it, and I'm going to get rid of that last portion. Okay, so I'm creating another layer, and I will do the same thing with this layer and paste it here, and I will do one more layer, and this last layer will have one neuron, and I'm going to use the sigmoid function. All right, and this right here should be our neural network. So this is one layer of the neural network with 32 neurons, each neuron using the activation ReLU function. This is the next layer, 32 neurons, third layer with 32 neurons, and the last layer that uses one neuron. Okay, so I'm going to go ahead and run this. Hopefully there's no problems, and there aren't any. All right, so I'm going to go down here to the next cell, and I'm going to say model.compile, and here we need to tell it the optimizer. So I'm going to use an optimizer called SGD. Then I need to tell it the loss function. So the loss function will be binary underscore cross entropy. And then I want to know the metrics. So we're going to get the accuracy. That's the metric that we want. And that should be it. I'll move this over a little bit. And so what this is basically doing is, well, the loss function measures how well the model did on the training. And we haven't trained our model yet, but we will. And then the optimizer tries to improve it, tries to improve the model. So I will put that in the comments here. I'm going to put loss function measures how well the model did on training, and then tries to improve on it using the optimizer. Okay, so let me go ahead and run that. And it looks like I have a few errors here, so let me see what the issue is. It looks like metrics equal accuracy. Okay, so make sure why is metrics. Just go down here, and okay, so we have our optimizer SGD. Our loss function is equal to binary cross entropy. I did not spell that correctly. Entropy. Let's go ahead and run that again. All right, now we no longer have any issues. Okay. So I'm going to create a new cell. And here we're going to train our model. So here I'm just going to put train the model. And to do that, I'm going to create a variable called hist and set it equal to model.fit. Okay, so fit's another word for train. And I need to tell it what data to train on. So we're going to train on the x underscore train data and on the y underscore train data. And the batch size will be 32, and it's going to have 100 epochs, so it's going to run 100 times. And then the validation data, we need to tell it what that is. That's going to be our x underscore val and our y underscore val. So this will help us. This will help us to see how well our model performed thanks to that validation data. All right, so I'm running it, and we can see the epochs here. So this is one epoch. And it's going to keep doing this 100 times. Let me scroll down so I can move over. And so what we get the loss value, the accuracy score for the training set, and then we get the not the same values, but we get the value loss and the value accuracy for the validation set. Okay, so I'm going to scroll on down here. I'm going to create a new cell. All right, now we want to evaluate the model. So I'm just going to say model dot evaluate, and we're going to evaluate the model on the testing set. So x underscore test and y underscore test, and I only want the accuracy, so that's why I'm putting this bracket 1 here, is because that's where the function returns the accuracy, which is in the second element, which is at position 1. And let's go ahead and run this. And we can see that the model is about 87.67% accurate. So that's pretty good. And I'm going to add another cell here. And now let's make a prediction. So I'm going to create a variable called prediction and set it equal to model.predict. And I'm going to predict on the testing data set. And if we run this, oh, I need to print it out. So let me print prediction. All right, so now if we run this, what we'll see are values between 0 and 1. So this basically gives us a percentage of what the model thinks. So right now this is, let's see, 0.03, that's 3.8%. So these are all percentages, and what we really want is more of a classification type of data. So to do that, I'm going to use a threshold, since it's just giving us percentages right now. So it's like saying the model is 98% sure that its price is above the median price, or it's 33% sure that the model's above the median price. Okay, so that's what these probabilities are telling us. All right, so I'm going to create a threshold. I'm going to say prediction is going to be equal to 1 if y is greater than or equal to, let me see how accurate I want this to be, maybe 0.87, since that's the accuracy that we got back. I'm just throwing out that number there. Else it's going to be 0 for y in prediction. Okay, so now we should get 0 and 1s for our prediction. And what we saw before was that y was like 0.03, so that's again about 3% for that first one, and of course that's less than 87%, so we get 0 there. And we should probably take a look at the y test. So we should look at what the actual values are. That's in y underscore test. And so I'm just gonna put print here, print prediction. All right, so now let's run this. Okay, and so we can kind of match it up a little bit. So we can see 0, 0, 0, 0, 0, 0, 0, 0, but then we see some mistakes: 0, 1, 0, 1, 1, 1, 0, 0, 1, 1, 0, 0, 1, 1, 0, 0, 1, 1. So it looks okay. Anyways, for now, let's really see how well our model is doing, or how well our model did with the training. So we're going to visualize it now. So I'm going to create a new cell, and here we're going to visualize the training loss and the validation loss to see if the model is overfitting. All right, so to do that, I just type plt.plot. So that's the plot that we want, and I want hist.history. So I want the loss of that, and I'm just going to copy and paste this. So Control C and then Control V, and we're gonna get the val underscore loss as well. We're gonna plot that, and then I'm gonna give it a title. So we just say plt dot title, and I'm gonna call it model loss. All right, and then I want to give the y-axis a label. So I say plt dot y label, and we'll call it loss. And then need to give the x-axis a label. So we say plt dot x label, and it's going to be our epochs. Okay. All right, and let's give it a legend as well. So we just say plt.legend, and the legend is going to be on the training set, and then our validation set, and we can put its location in the upper right. So let's go ahead and run that, and we can see that the training and the validation set look very similar. So from this visualization or this graph, it looks like our model's not overfitting. I'm going to create a new cell, and this time let's do the same thing, but for the accuracy. So I'm just going to take all of this information, click Control C to copy it, and come down here in this new cell and click Control V to paste it. And I'm just going to change it up a little bit. So we're going to visualize the training accuracy and the validation accuracy to see if the model is overfitting. And so instead of loss here, we're going to put ACC, and instead of loss here, we put ACC, and this is the model accuracy now. Accuracy. So I'm going to change the title to model accuracy. The Y label will be the accuracy, and the X label will be the epoch. And of course, we keep the train and val the same for the legend. And I'm going to put this in the lower right, and then let's run this. And so down here now we can see that the accuracy models basically match for both the training set and the validation set. So that's pretty good. So it looks like our model's not overfitting. All right, so that's basically it, guys. I hope you enjoyed creating your deep neural network model, and I'll be sure to put this code up on my GitHub and a link to that in the description below. So if you have any questions, please leave comments. Don't forget to hit that like button and that subscribe button to subscribe to this channel for more videos on Python, machine learning, and programming in general. And if you found this video helpful, please share it. And as always, guys, thank you for watching, and I'll see you all in the next video.